Hello, guys. Today we are going to start a very important and interesting topic in natural science energy transfer in electrical systems. This means we are going to learn how electricity flows through circuits and how different parts of a circuit works together to allow that energy to be transferred. By the end of this lesson, you can will understand how electricity travels, what makes a circuit work, and how we can control it. Current electricity is the electricity that moves. It's not just sitting still. It's the electricity that flows through wires in your home, in your phone charger, and in light bulbs. This flow of electricity is caused by tiny particles called electrons. For these electrons to move, they need a full path or loop to flow through. That loop is called a closed circuit. If there is a break in the circuit, the electricity can't flow. The energy to make this happen comes from a source like a battery or a cell. For electricity to flow, we need a few important things. First, we need a source of energy. This can be a battery which is stored chemical energy and changes it into electrical energy. Then we need conductors, wires that connect all the components that allows electricity to move through. But the electricity won't move through the path when the path is not closed, which means all the parts are properly connected with no breaks. Lastly, we need a loud or device that uses electricity. This could be a bulb like a light bulb or a motor or any component that does something with the energy. Like for instance a light bulb that can make light or a buzzer that makes a sound or a remote control that if you press it the TV goes on or anything like that. Now let's look at the parts or components of a circuit. Each component has a specific job. A cell gives us the energy to start the flow. A battery is more than one cell joined together to give even more energy. Wires connect everything and carry the electricity. A switch can stop or allow the current to flow. A closed switch lets the electricity move. An open switch lets the electricity stop. A resistor slows down the current to protect other parts of the circuit. A bulb, like a light bulb, will light up when the current flows through. An ammeter tells us how strong the current is, and a voltmeter tells us how the voltage. We use symbols to draw circuits because it's quicker and easier to understand diagrams that way. So as you can see, the component, how a symbol looks, and what the purpose is. Every working electrical circuit must have at least these three things. First, a source of energy, of power. This gives us a push for electricity to move. Second, something to carry the electricity, usually copper wires. And third, something that uses electricity, like a bulb that lights up. If you take away one of these things, the circuit will not work. So, very important, a source of energy, a conductor, and the device. So, how does batteries work? Inside a battery, chemical reacts to produce energy. When the battery is connected in a circuit, the chemical reaction begins and produces electricity. This electricity flows through the wires. If the circuit is broken, the reaction stops. That's why switches are useful. If the switch is off, the circuit is open and electricity stops. When the switch is on, light switch, the circuit is closed and the light will go on. Over time, the chemicals inside runs out and we say the battery is flat. Rechargeable batteries can be used again because they allow the chemical reactions to reserved using an external charger. Or you must just use a new battery that is full of electricity flow. A switch gives us control. So think about a light switch at home, as I said. When the switch is off or open, the electricity cannot move. When the switch is on, so basically current is closed, the electricity can flow. We can use switches in many devices to turn them on or off. They are important for safety and saving energy. So as you can see here on the left, it's an open switch. So it means the switch is off. Electricity can't flow through. On your right, you can see a light switch that is closed. So basically, the switch is on. Basically, in other words, that means the light bulb is on. It's lighting up. So, why a light bulb might not work? Sometimes, even if you think your circuit is complete, the bulb won't light up. There can be many reasons. Maybe the switch is open, maybe the wires are not properly attached, or a wire is broken. Inside the bulb, there are tiny wires called filaments. If that filament is broken, the bulb will not light up, even if the rest of the circuit is working. A resistor is a part of a circuit that resists or slows down the flow of electricity. This can help prevent damage to other parts. Think of it like a speed bump. It doesn't stop the traffic, it just slows it down. Inside a light bulb, there are thin wires called filaments. These wires heat up and glow when electricity flows through it. That's a type of resistor. So it just makes the electricity slower so that it doesn't damage the other components of the circuit. Where do we use resistors? Resistors are everywhere. In light bulbs, they help make light. In your phone and computer, they control the flow of electricity. In chargers, they stop too much current from going into your phone. And without resistors, many devices would get damaged or stop working properly. Conductors are materials that carry electricity well. We mostly use metals like copper because they let electricity move quickly and easily. Wires are made of copper, but they are covered with plastic. The plastic does not conduct electricity, so it protects us from getting shocked because the electricity can't get through to us. That's why it's important to never use damaged or exposed wires. You will get shocked. So let review. Electricity only flows in a closed loop. That's a circuit. We need energy, wires, and something like a bulb or a buzzer to show it's working. We draw circuits using symbols. Switches control the flow of a resistor and slows it down. And batteries gives us the energy. And always remember, wires carry electricity, but they must be safe to touch. So cover them with plastic so you won't get shocked. Thank you so much for being a great class. I hope this lesson helped you understand the flow of energy in electrical currents. Keep reviewing your notes and practice drawing circuits diagrams with symbols. And remember, electricity is powerful, so always use it safely. Good luck with your studies and upcoming assessments. Bye, guys.